Hey, Math B. This is Mr. Osborne here. I just want to do a quick little intro face-to-face before this video switches over to the document camera and explains the Math B integer subtraction poster project. Don't make this bigger than it's meant to be, okay? It could be on an 8.5 by 11 piece of paper, as long as it's completed sufficiently. You could do it digitally. Those are options you have to be creative. This little video is meant to help you sort of wrap your head around what an example draft might look like. Let me repeat, you will see a draft. Okay, I'm going to stop here and we'll soon switch over to the document camera. Okay, hello there, Math B. This little video is Mr. O's attempt to give you sort of a draft example of the integer subtraction poster project. This is not poster, something large. It could be as small as an 8.5 by 11 piece of paper. You can do it digitally. I'm going to do this little example on paper, and this will be a draft. So what you see, I am not considering a finished product at all, but I wanted to give you something to go by. So the objective is to create a poster that shows how to model integer subtraction two ways, as a subtraction problem and as an addition problem. So the same problem shown in these two different ways, because remember, subtraction is adding opposites. So some things your poster should have is the use of positive and negative tiles. You should have a numeric expression that represents those tiles, and the tiles represent your expression. You want to have words that guide the reader through the steps and determine your answer. There needs to be zero pairs involved in your explanations at some point through the process. And then you want to be able to show the model as well in a number line. I'm not going to go in detail over criteria, how it's being scored, other than it's going to be scored for its readability, the accuracy of the math, that is how the words in the drawings and numbers all match up, and then sort of degree of difficulty. The only comment I'll say about degree of difficulty here is that the kind of problem that would not be appropriate is something you'd see in elementary school. So a big number, subtract a small number. You did this in elementary school. This would not be middle school appropriate. We want to do something with the integers we've been exploring this semester. So with that in mind, here I go. Wish me luck. Remember, this is going to be a draft. I'm not going to consider this a final product, but I am going to attempt to do this work with this problem here, 2 minus -6. So I'm going to first sort of show this with tiles. And so what I've got is I'm starting off with 2, and it's saying take away a -6. It's saying take away, let's take away -6, right? But there are no negatives. Let's point that out. There are no negatives, right? All I've got to start with are these two positive tiles, right? So how can I take away any negatives if there's not any to start with? Well, the way I can do that, so I'll put this in a little box maybe, help the reader. Looks like I'm going to need to add 0 pairs. Neatness already is an issue. Okay, so there's one negative, right? Because together that makes 0. There's another 0. There's another 0. How many up to? 1, 2, 3, 4, 5, 6. Oh, and there I go. Now I've got 6 negatives to take away. So you know what I'm going to go look at that. I might do something like this. Take away -6. So hopefully that makes sense. We've seen this in the CPM book. And then what do I have left? What I have left is my answer. My answer is 8, right? Because I have 1, 2, 3, 4, 5, 6, 7, 8. So 2 minus -6 equals 8. So let's show this on a number line. Let's see, I'm going to go like this. I'll use a straight edge, right, because the least I can do is. And I'll put some tick marks here every so often. Should at least have enough to get to 8, right? So I'll do 0, 1, 2, 3, 4, 5, 6, 7, 8. And of course, it continues on 9 to 1. So what's this saying? This is saying I start at 2, so I've got 2. And then I've got my person. Since it's subtraction, I want to face left. So subtraction. Lacks some neatness there. Face left. Maybe that needs to be in some kind of face left. Let's see, here's my little, yay! But I need to, since I'm moving, -6 or backwards. Since I'm going negative, I need to move backwards. Backwards 6. So my guy's going to actually move this way, isn't he? 1, 2, 3, 4, 5, 6. And lo and behold, we're at 8. So let's see. I've got the expression. I've got some tiles. Look, I even added some 0 pairs in this example. I've got a number line. So that part's okay. And so I've modeled with subtraction. Now I need to model the same thing with addition. So let me put down my original problem here. Okay, as addition. So what do we know about addition? We know subtraction is, let me remind myself, subtraction is adding opposites. Boy, this really is a draft, isn't it? I'm going to need to move my camera here a second, so bear with me while I start doing an adjustment. Okay, hopefully that'll, let me try that. So remember, what do I do? That means I'm going to keep the first one, keep the first value. I'm going to change, and then I want the opposite. I think I've told some classes, KCOP, keep, change, opposite, opposite. So let's see, what does that mean? I'm going to keep the 2, right? I'm going to change the subtraction to addition, and then I want the opposite of -6, which is 6. That should be pretty easy to set up as tiles, right? Because it's saying start with 2, and then combine it with 6 more. 1, 2, 3, 4, 5, 6. All together, there's my answer, right? There's nothing to cancel out. There's my answer. So that's saying what? That is saying 2 plus 6 equals 8, which of course we know because that goes backwards. Let's think about this as a number line for a moment. So 1, 2, 3. So if I do 0, 1, 2, 3, 4, 5, 6, 7, 8. In this case, what are we doing? We're starting out with 2 again, just like in the previous problem. But now we're adding, right? So when we add, we face to the right. Let me go, here's my little guy. Yay! And he's going to face to the right. My little, I don't know if that's his nose or if that's him looking. And he's going to, this time, what he's going to do, and since he's adding a positive, you see, he's moving a positive. What did I say? Move. Yeah, when we move positive, we go forward. So if we're supposed to combine it with something that's positive, we're going to move in the forward direction, which means we go 1, 2, 3, 4, 5, 6. And lo and behold, we're back up to 8, just like we did. So as a little wrap up here, if I can move my paper, we can see that 2 minus -6 is equal to 8. And 2, which is the same thing as 2 plus +6, is equal to 8. Well, so how did I do here? If we did a little review. Well, I certainly have the tiles I've got one zero pair in at least one of these examples, right? It's right here. I showed it on a number line. Clearly, I could make this more readable by being neater. I can probably make it more readable by putting in some boxes, kind of direct thinking. Maybe I need to sort of do a little line to separate out the two models. So, but as we said before, this is a draft, and I could use this, and I could work with this to make a completed poster. So I do hope this has been helpful and not too long, and I look forward to you guys doing a much more awesome job than I have done here. Bye for now. Remember, ask questions, be ready to share because you'll be working on this really soon.